All right, so we are going to look real quick at some examples where the goal is to factor a greatest common factor. I've got here a polynomial with three different terms. I'm going to imagine this as being just this group, and there are three terms. And if we want to factor a greatest common factor, we're looking first at the coefficients to see what is it they all have in common. One way to think about this is 6 is the same thing as 2 times 3. And why focusing on the number 2? They're all even numbers. Now, over here in the next term, it's already got a 2. This is great. But the 4, you can think of it as a 2 times a 2. And so when we're factoring, we're taking what they all have in common. In this case, it's a 2, and a 2. And what's happening with this is it is going to, usually we write it out here in the front. We say, okay, this is us factoring. But what you're thinking of it is almost as if you're undistributing. Okay, so if you're familiar with the distributive property, usually that's when we have some number out in the front and it gets multiplied into each of the terms. But what we're doing is we're almost thinking like we're going backwards, which instead of we're not doing multiplication, we're doing division. And so that's another way you can think about this is, well, if I've got these numbers and I know that they have a factor of 2, well, maybe just think about it that way. This is divide by 2, this is divide by 2, this is divide by 2. And so that factor, we'll write it out here in the front. Now I'm leaving a little bit of space here, and that's because there's still more that we could factor from each of the terms. But if you're thinking of it as 6 divided by 2, that gives us 3. 2 divided by 2, I'll be specific, negative 2 divided by 2, that's going to give us a negative 1. And then 4 divided by 2, that's going to give us a 2. Now I'm trying to leave space here, 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 and here, and that's because they still have these variables that are a z that we've got to do something with those as well. Now, just to keep things clean, we're done with factoring the numbers. They all had a 2 in common. But now in terms of this letter z, well, this one's got 1z. The one in the middle has a z squared. You can think of it as z times z. And then the first one's got a z cubed. You can think of this as z times z times z. And so what they all have in common, this one's got a z, this one's got 1z, and this one's got 1z. Same thing, think of it as undistributing, where instead of multiplying everything by a z, we're dividing everything by a z. So it's going to come out here as the common factor that they all have. And so what will be left over after that's gone, it'll be in the first position, z times z, which is z squared. In the second position, just a z, and in the last position, nothing. And so this would be the factoring for this, again, just to kind of keep things looking clean. And you can check yourself, like, is this true? Is this 2z the greatest common factor? Well, if you imagine yourself distributing, z squared, 2z times 3z squared would give us 6z cubed. That's good. And then if we were to multiply it over here, that'd give us a negative 2z squared. And if we were to multiply that factor times this last one, that would give us a 4z. So this would work. Now the one that I have there in the middle, you don't need it. Since it's a leading coefficient, it's a coefficient of just 1, that would work. This one here is very similar in that we're trying to just factor a greatest common factor from each of the terms. Again, notice this time that they're all divisible by 3. Whenever your lead is a negative, usually we want to factor that out as well. So what we'll do is we'll just imagine ourselves, well, so since we know they're all divisible by 3 or multiples of 3, and we want this negative in here to be gone, imagine ourselves dividing everything by negative 3. So that negative 3 is going to sit here in the front as the common factor that they all have. Again, imagine it as though we're undistributing. But as far as updating your numbers, again, leave a little bit of space here, is just think of it as negative 3 divided by negative 3 is positive 3. Positive 6 divided by negative 3 would be a negative 2, and a negative 3 divided by negative 3 would be a positive 1. Again, notice that I'm trying to leave space because we still need to decide what's going to happen with the variables. And again, just to kind of keep things clean, I'm going to move these out of the way. And so what do they all have in common? This here is an x squared. This one here in the middle is like an x squared times an x. It's an x cubed. And then this first term is an x squared times an x squared. So notice that they all have an x squared, an x squared, and an x squared in common. And that's what's going to come here in the front as part of the greatest thing that they have in common is an x squared. So we'll write our x squared right here. Again, that is leaving out as the common part of the greatest common factor. So this one here is gone. Maybe I'll just do it this way. This guy's gone. This is gone. This is gone. And so that's what will remain still within the parentheses as the as part of what remains in each of the terms. So this x squared is still here. This x is still here. But this one is gone because it's now way up here in the front. Okay, and again, just to kind of keep things looking pretty, I'm just going to, these are all the things I'm erasing, just kind of what's going in my head as I'm doing this. But to check ourselves, again, if you were to multiply, imagine this factor up here in the front as us being redistributed. That would be negative 9x to the fourth. And if we multiply that factor here, that would give us negative 3 times negative 2, which would be positive 6x cubed. That's great. And negative 3x squared, anything times 1 is still itself, so negative 3x squared. This would work. All right, so that would be the factorization for these first two if all we're trying to do is factor greatest common factor. There's still other things like factor by grouping, but I'll do that in a slightly different video, another video, and factoring trinomials. But at least that's just some factor by just GCF.